Manipulating data is very key to data engineering, and Kestra has a bunch of different ways that you can manipulate data inside of your workflows. But what is the best way to do that? Probably the easiest way to do this is by using the Python task. If you just need to manipulate some data or run a quick script, this is definitely the easiest and quickest way to do it. Now, if you're looking for performance and low latency, using the process task runner means it won't have any overhead where spinning up a separate Docker container. It will run it directly on the Kestra host as a sub-process. So this is definitely a good idea if you need performance, especially if it's just a short couple of lines of code. Now here, I'm downloading a JSON file with a download task, but then I want to be able to just get a certain bit of data from that. And so here what I'm using is, I'm simply using the Kestra library to be able to then generate a new output that I could then use later in a further task. Now, inputs and outputs are fairly straightforward here. You can do input files if you want, and you can also add environment variables, or if you're writing it in line, you can use an expression just like this to add your output from a previous task directly to your Python code. This is one of the ways that I would recommend, but there are a few others that you might want to consider. Another option to look at is using GraalVM. Now, what GraalVM does is it runs your Python code on the Java virtual machine, or the JVM, so it should offer some performance advantages. But do beware, at the time of this video, this plugin is still in beta, so there may be a few things that still need to be worked on. But what I really like about this plugin is, while I can easily just tell it what I want, I can give it the output here as an expression because it's all written in line, but I can just specify what data I want to then get out and use later on. So rather than having to use that Python library to export the variable as an output, I can just list out what I want to catch, and then I can just use that later on. I think this is a really neat way if you want to be able to just hand your task data, do a little bit of stuff to it, and then get it out of that task. I think this is a really clean way of doing it. And in fact, I have another example too. I actually used it for my performance tracking workflow, which will come out in a separate video, so subscribe to stay tuned for that. Now, what I was doing here was I had a subflow that was going to run whatever workflow you specified. So the idea is, if we go to the topology view, the idea is it will set a label to say what's going on, it will download a file, and then it's going to pass that file to a subflow, and it's going to run that in a for loop. So depending on what you specify it, you can say I want to run it 10 times, I want to run it 1,000 times, whatever you prefer. It will then run that subflow the number of times specified. Now, at the end of each of these subflows, it will then get data about that subflow using a request, thanks to Kestra's API first design. So we can then look at how long it actually took to run that workflow. And if we wanted to get really down to details, we could look at how long it took to run a certain task. And then this is where the Python code comes in, which is using GraalVM. I want to just be able to quickly hand it the response from my request, get the data out of it, do a little bit of maths on it so we can then pass that on and calculate our average runtime. So if we go and look at the workflow and we go look at the code now, you'll see that calculate duration is just simply getting the data from that request. It's working out what the duration is, and then it's just making it here, duration equals this. I've just specified the output here, give me the duration, and I can then access that later on. And as you can see here, I can access my durations from that workflow a little bit easier. So I think this is a great way of doing it, and I've done it again here with average too. So this is a really neat way of being able to clean things up a little bit. Another example is if you want to manipulate a file, the Python script task again is a great choice. Here I'm able to specify my input file, and I'm able to use an expression to get the file directly from the input. So here it will ask me to upload a file, or if I'm using a subflow, I can pass it there as well. And then I can just specify that the file inside of the Python will be called green trip data 2019-01. So it means inside of my Python environment, that file will exist. I can also specify what output files I'm expecting to get, so I can then get those in Kestra and then again pass those on to later tasks or just access them myself. And then the code is just here down underneath, and as you can see, it's going to generate a unique ID. It's then going to have to save the file too. Now, This can get quite long because there's a few bits happening, right? We've got to add logic for reading the CSV file. We've got to add logic for saving the CSV file. The new GraalVM FileTransform task helps to sort of solve this a little bit and clean it up a little bit. So while this was quite nice, I can actually go over to my GraalVM example. You'll see a very similar thing. Instead of having that input file, I'm just asking it for the file that it's going to get. Now, it does need to transform it into an ION format so that this task works effectively, but that doesn't take too long to run. Once I can then pass it over to this task, it's then going to automatically go row by row. So this row property will basically, block of code will run for every row, and then we can add a new row to it. So at the end, we'll get a new file without having to save it explicitly with any of the modifications we've made. So I am a big fan of this because it just allows you to then write less complicated code to get the same response, just making your workflows cleaner and easier to maintain. Now, it is worth noting that we have script tasks for more than just Python. In fact, we've got them for Go, Node, Ruby, even Shell. So if you just want a Shell environment where you can run any language of your choice, you can do that too. And this all, what I used with the Python script task, all works similarly with these other languages. So you aren't restricted to just Python. You can use a different language, maybe something that's faster or more suited to your team, but it allows you to manipulate data. Now, you might find yourself wanting to store state from these tasks as well. So not only do you want them to be able to manipulate something, you might want it to just store the state or maybe the last value it received so you can access that next time. Now, if we run this workflow for a quick example, right, it's going to run really quickly and we can see it's produced a random number. Now, I can actually use the key value store here to be able to store that and then access it next time. So let's just do that with a new task type. So what we've got now is a key value store set up so we can get the value, access it inside of our code, and then we can also then set a new value to access later. So if I execute this workflow now, we can see that it's fetched the value, which there wasn't any at that time. We can see that if we go to the logs, it'll be a little bit easier. We can see that it's printed out that the value was 0 because I told it if it's null to print 0, but now it should have stored the new value, which in this case was 100. So if I execute this again, what we're going to see is it's going to print out 100 because that's what it stored last time. So let's say there's all sorts of examples you could use, like making an API request and wanting to store the last time it was run. Timestamps are a fantastic example. So this just helps you allows you to store values and then access them later without necessarily needing to make them outputs. So just think about that as well when you're trying to manipulate some data with scripts and you might need to just store a state for a brief moment. Now, hopefully that gives you some of my tips on manipulating data in Kestra. Now, you can use expressions too if you want to do some of this, but it gets quite messy and difficult to debug. So I definitely would push you more towards using the Python script task as well as the GraalVM. Now, especially make sure that you use the process task runner if you're looking for performance, especially for those smaller tasks that, one, don't rely on lots of libraries, and two, don't need the isolation from a Docker container. Hopefully that was useful, and if you want more tips on manipulating data, let us know in the comments below so we can make more videos like this.